Now the black carbon, we've all driven behind a bus and you see the black carbon coming out of the, or soot coming out of the exhaust. It has always been hypothesized, and certainly we do this in models that we do of the atmosphere, is that once black carbon is emitted in the air, it becomes coated with these other condensable species like sulfates and organics, and when we do climate calculations, we always assume that within a day or so, that all the black carbon that's emitted worldwide gets coated with these other components, the sulfates and the organics. We had an instrument on the plane. It's a new instrument that measures black carbon particle by particle in a very clever way. By zapping it with a laser, the black carbon incandesces, and it'll measure from the incandescent signal the amount of black carbon that's there. But it also has a scattering part to it, and it can measure if there's a coating on the black carbon. And so this is a plot of the diameter of the black carbon. So think of it as a black sphere surrounded by a coating of some not an absorbing material, like a transparent. Think of just a water coating, although it's not water. And this is a measure in West LA. It showed that and this is by a relative number. So most of the black carbon in West LA had a diameter of about 150 nanometers. So this is, 100 of these would fit in the diameter of a human hair. I mean, these are very small. And the coating thickness, there was a coating thickness. These get coated very quickly, of about 50 nanometers. So you've got 150 and then a coating. In the outflow to Banning, so out the pass to Palm Springs, what has emerged here is a coating that's up to 200 nanometers thick. So what's happening as these black carbon particles traverse the basin is they're picking up this gas phase material, and it's condensing on them as this coating of liquid. And so this was really the first measurement that really showed this. It was made possible by the invention of this instrument. So now this is going to allow a really important studies on what happens with black carbon. We're also measuring this oxidation state, and as one expects that as the air flows from center basin on out to the desert, these particles do become more oxidized. This is the atomic ratio of oxygen to carbon in the particles. I want to end with some comments about climate. So particles, of course, are very important in a pollution sense. It turns out they're also very important in climate. This is an airborne picture of LA, and this is a smoggy day. And what the result here is that in looking through this haze, you can't see the surface. And the sunlight is being reflected back to space by the particles and is being prevented from reaching the surface. So that means that when you have a layer of particles like this, the surface is not going to warm up as much as it would without them. Now this is LA. This is off the east coast of the U.S. And so this is the same kind of material as we just saw over LA, leaving the east coast of the U.S. out over the Atlantic. And so this is where we saw that in India in the beginning. So the presence of these particles is a cooling influence on climate by preventing the radiation from reaching the surface. It turns out that particles play another very important role in the Earth's climate. clouds form when water vapor condenses on an airborne particle. And if there were no particles in the Earth's atmosphere whatsoever, there would be no clouds, and it would be a totally different planet. So the particles play a climatic role as the seeds on which clouds form. Since the Industrial Revolution, the last 100 years, 150 years, the amount of particles in the air has gone up by a factor of 2 or 3. And so the question is, what effect has that had on the Earth's cloudiness? And I just have this one slide. This is a satellite picture off the west coast of the U.S. This is Oregon and Washington. This is a day when the ocean is covered by a layer of marine stratus. We've all seen this flying out over the ocean. These are low-lying clouds. And when ships sail underneath the cloud deck and the exhaust of the ship rises up and gets into the cloud, it produces a signature in the cloud. This is the cloud reflectivity, or the albedo. These things are called ship tracks. And it's a natural way, well, not natural because the ships are causing it, but of studying how an increase in particles changes clouds. And that's still a very active area. And on the whole, that's also a cooling influence, because these clouds are getting brighter, which means more sunlight's getting reflected back to space. How much cooling is still one of the major questions, and the IPCC report goes into this in some detail. This is important in terms of future climate. Imagine that there's no aerosol cooling effect on climate. No, so the global temperature has increased by about 0.8 degrees centigrade from the 19th century to today. 0.8 degrees centigrade global average. And so that would be reflected, let's say this is 1, so this is about 0.8. And now, if there is no cooling effect, no particles there, then that 0.8 would represent, the full extent of heating that CO2 and the other greenhouse gases would be imparting to the Earth, and if that could be extrapolated with various scenarios. But now imagine that there's this much greenhouse gas forcing, but it's being counteracted by, say, this much cooling. That means that 0.8 degrees resulted from this, not from this. So therefore, the so-called climate sensitivity of the Earth is higher. And in that case, we're going to get a much higher rate of warming, because the particle levels are staying pretty much where they are or even decreasing. But the greenhouse gas levels are increasing, and so that this is a constant. So here's a measure. It's just a rough measure of the effect of understanding the role of particles on future climate. So let me end with a few comments. First, humans are responsible for the warming that has occurred. This is unequivocal. The measured change in the Earth's energy balance, which can be measured very precisely from satellites, is beyond that which any natural factor, the sun or anything could cause. The organic compounds are about half of global particles. Their chemistry and oxidation state are complex. Connection to effects on human health is certainly a very important issue. Aerosols on balance cool the climate. and act to cancel some of the greenhouse gas warming, but the magnitude of that cooling is uncertain. And aerosols are being reduced because of their effect on human health, and they have to be. As this occurs, the full impact of greenhouse gas forcing will be unmasked. It's like taking away this little cooling influence. So with that, thank you very much. And